Hello and welcome to this question video. So we'll start off with writing formulae for compounds. So how this video is going to work is I'm going to pause, you press pause and have a go at the questions, and we'll go through the answers after the jump cut. So for question 1, we're writing the formula for magnesium nitrate, lithium sulfate, calcium nitride, sodium sulfide, potassium phosphate and aluminium carbonate. Okay, so the answer for part A is MgNO3 twice, because we know that a nitrate ion is minus and Mg is 2 plus. So the way to represent this is to put brackets around the nitrate and to write a subscript 2 here. And for this one, calcium nitride, if we know that nitrogen forms a 3 minus ion and calcium forms 2 plus, we need 3 calcium to cancel an overall 6 minus charge for N2. And for potassium phosphate, this is the most difficult ion to remember. But if you remember PO4 3 minus and potassium being plus 1, I'm just going to put plus there, you need 3 potassium to cancel 1 phosphate group. And for part D, lithium sulfate, if we look at the periodic table, lithium is plus 1 and the sulfate has an overall charge of minus. And for part E, sodium is plus 1 and the sulfate again is minus 1. So, or 2 minus and 2 minus for this one. So we need 2 of these and 2 sodiums again. It's easy to trip yourself up, but if you know that 4 times 8 is minus 8 because every one oxygen atom is 2 minus, and knowing that sulfur can hold up to 6 electrons in its outer shell, then two electrons will always be gained on those atoms. But I'll talk more about that in oxidation numbers. What you need to know now is the charge of a sulfate ion, and knowing that it's 2 minus, not 1 minus. And for aluminium carbonate, Al 3 plus and carbonate is 1 minus. So in order to cancel an overall 6 plus charge on Al2, we need the 2 minus for carbonate. We need 3 carbonate atoms or molecules rather to cancel 2 of these. So we get Al2CO3 3 times. So now back to the questions. Now we need to work out the relative formula mass for each of the above compounds. Now I'm assuming that you got all of the questions right in the top. Then you'll be able to work out all the molar masses for magnesium nitrate, lithium sulfate, calcium nitride, sodium sulfide, potassium phosphate and aluminium carbonate. And I'll pause for a few seconds. Okay, so the relative molecular masses for these, for A, magnesium nitrate is 184.5, calcium nitride 148.3, potassium phosphate 212.3, lithium sulfate 109.9. Zero is just there for significant figures, so if your calculator comes up with that, then well done. I've just put the 0 there because I like having the 0 there. And finally, for an aluminium carbonate, you get exactly 186. And we'll move back to question 3, where you have to name the following molecules. Now for part F, you need to know about the charge of iron. I'll give it to you, being 3+. Okay, so A is ammonia, and B is carbon dioxide, C is sulfur dioxide, D is methane, E is calcium carbonate, and F is iron-free chloride. So since you know I told you that iron has a 3+, then and CO3 would have an overall charge of 3-, but each CO atom has a 1- charge, so you need 1 iron atom to cancel out 3 chlorine molecules. So we'll go back to questions again, and now we're going to work out some moles of the following. So 1.7 grams of ammonia, 3.4 grams of calcium sulfate, 8.1 grams of SO3, and 41.6 grams of barium chloride, 0.8 grams of sodium hydroxide, and 21.25 grams of sodium nitrate. So I'll pause again. Okay, so now go back to the answers. And 4A is 1.7 grams over the molar mass, which is 32.1, which is the value of the sulfur, and 3 being the molecular mass for one hydrogen atom times 3, or 3, and that gives you 0.048433 recurring on 2 dots. Do not express it as recurrent in the exam. Delete the dots and just have your full calculator display, and if you want to round it to 3 significant figures, it's probably better to round it to 0.484. So if you got this one, I'll give you bonus mark, but if you have rounded to 1 significant figure, I'll still give you the right answer. But 3 sig fig seems to be what the examiners want nowadays. I know, because I do it. It's pretty bad. So the next one is 80.1 over 32.1 plus 16 times 3, which must come to 80.1 exactly, as we get the answer of 1 mole. And for part C, silly me, we get 0.8 over 23 plus 16.1, which equals 0.02 moles. So moving on to part D, 3.4 over 120.2, which is 40.1 calcium plus 32.1 nitrogen plus 16 times 3, and that gives you 120.2, and you get 0.028286 moles. So rounding it up, we get 0.0283. But if you're doing any further calculations, always use your full calculator display, as it retains the full accuracy of your moles. And for part E, 41.6 over 345.6. So working out the MR, get back to the question. Barium chloride. So knowing that barium is in group 2, it's a plus 2 charge, so we have 137.3. We need one atom of that, and we need 2 Cl atoms in order to cancel out the plus 2 charge. So we need 35.5 times 2, and that gives us 208.3. So 137.3 plus 35.5 times 2 is 208.3. So I will correct that. And recalculate. And we get 0.1997195 to the dot, or 0.199 moles. And finally, for part F, we have 21.25 grams over sodium plus nitrogen and the 16 times 3 again. By the end of your course, you will know the 16 times table. And you get 0.21 moles, or 0.26110573. But that's only if you want to keep it accurate for other questions. So we'll move back to the questions, and I'll talk you through that. So looking at this, we need to find out what 1 mole of hydrogen bromide is, 1.5 moles of potassium iodide, 0.90 moles of sodium sulfate, and 0.1 moles of iron sulfate .7H2O. It's hydrated, that one, and 0.04 moles of calcium hydroxide and 0.12 moles of barium bromide. So you need to work out the formulas of the ones you don't know, and work out the MRs for these ones, and then use the mole equation, which is moles equals mass over MR, in order to work it out. So have a quick pause. Okay, we'll go through the answers now. So question 5, this one. So A, 80.9 grams, bromine plus hydrogen equals 80.9, and 0.9 moles times 2 sodiums, 1 sulfur, and 4 oxygen atoms, which gives us 127.89 grams. 1.5 times 39.1 plus 126.9. So 39.1 is potassium, and 126.9 is iodine. So potassium and iodine, that gives us 249 grams. And we have 0.1 times 55.8 plus sulfur 32.1 and 4 oxygens, plus 7 times, this is the hydrated salt water bit, we get 7 times 18 basically, and that gives us 27.79 grams. 0.12 times 137.3 plus 79.9, that gives us 26.064 grams. And 0.04 times 40.1 plus 17 again, which gives us 2.284 grams. So number 6 is some empirical formulae questions. So I've got the percentage by mass. Just need to calculate the empirical formula for all of these. And a quick pause. And we'll go through them. So for 6A, the ratios are sodium to sulfur to oxygen. So we have 32.4 grams of sodium. We get 1.40869 moles, and 22.5 over 32.1 molecular mass of sulfur, and we get 0.7009 moles. Keep the in the calculator display in order to retain full accuracy for empirical formulas. 45.1 over 16 gives us 2.81875, and this is the dividing by the smallest part, 0.7009 moles. That gives us 2. I'm rounding it up. It does not give you exactly 2. It gives you 2 point something. And the same here. Always gives you 1 when you divide it by itself. And this is about 4. So the empirical formula is Na2SO4. Da-da! And now we go to 6B. Hydrogen to phosphorus to oxygen now. So 3.66 over 1 is, surprisingly, 3.66 moles. And we have 37.8 grams over 31.00 the molecular mass of phosphorus, and we get 1.2193 moles. And 58.5 over 16 gives us 3.65625 moles. So divided by the smallest, we have H3PO3. And for 6C, carbon to hydrogen ratio, so we have 88.81 over 12, and that gives us 6.8175. Ignore this bit for now. And 18.8 over 1 is 18.8. So divided by the smallest, we have 1 to 3, so it's CH3. And that's H3PO3. And we move back to the questions now, and we go for some hydrated salt ones. This is another molecular formula question. So first we have to calculate the empirical formula, and knowing that the relative molecular mass is 28 grams per mole, we can work out the molecular formulae. So I'll give you a quick pause, and we're going to look at the question next. And you get 85.7 over 12, which gives us 7.1466 moles. Put your units there. And we get 14.3 over 1 is 14.3 moles. So we have a 1 to 2 ratio. If we divide 14.30 by 7.14166, it will be about 2. So really I should put approximately equal to 2. So the empirical formula is CH2. So now working out the molecular mass of the empirical formula, we have 14 as our MR. And knowing that the MR of the original molecule was 28, we get exactly 2. So 2 times CH2 is C2H4, and that's the molecular formula done, calculated. Now we go back to the questions. And we have 5 grams of hydrated sodium sulfate crystals, which is this formula here. Gives us 2.2 grams of anhydrous sodium sulfate on heating to a constant mass. So we need to work out the relative molecular mass of the hydrated sodium sulfate and the value of N. Really, it should be the value of N first, otherwise you can't do anything in order to work out the relative molecular mass of the hydrated sodium sulfate, but hey. So I'll give you a quick pause. Okay, moving on to question 8. So, it's always nice to start off with an equation for these ones. So if we write out Na2SO4.NH2O equals Na2SO4 plus NH2O, it doesn't actually go like this, but once you heat, you always get like that. So 5 minus 2.2 is 2.8 grams units, and then 2.8 over 2 times 1 plus 16, or 18 to you and me, we get 0.15 dot moles, or to 3 sig fig, that would be 0.155 moles. But keep the recurring bit in your calculator so it knows to do it to more accuracy. And knowing that we have 2.8 grams of water and 2.2 grams of sodium sulfate, we work out sodium sulfate MR, which is 23 times 2 plus 32.1 and 16 times 4. We get 0.015 moles. So big number over small number gives us 10. So N is 10. So the MR of Na2SO4.10H2O equals 322.1. So going back, we have 23 times 2 plus 32.1 plus 16 times 4. Stop. That is the sodium sulfate, plus 10 times 18, which is 1 plus 1 plus 16 for the water. We get 322.1 as your molecular mass. Molecular mass has no atomic units, well, SI base units, so we just put MR equals 322.1. And now going back to question 9, the final question for this tutorial, question video. 6.75 sample of sodium carbonate .X2O was heated to a constant mass 2.5 grams. Find the value of X. So using the same method as before. I'm going to pause for a bit. Okay. We go down to question 9. 6.75 grams of sodium carbonate .X2O with 2.5 grams of the anhydrous. So Na2CO3.X H2O gives us sodium carbonate plus XH2O. Nice to start off with an equation to know where you're going. 6.75 minus 2.5 is 4.25 grams. 4.25 grams of water and 2.5 grams of sodium carbonate. So first we work out the moles of sodium carbonate. 23 times 2 plus 12 plus 16 times 3 is 106. So 2.5 over 106 gives us 0.023589, and it goes on pretty much until my calculator display ends. So to 3 sig figs we have 0.0236 moles, and for the water 4.25 over 18 gives us 0.2361. So to 3 significant figures we have 0.236 moles. and we have big number over small number. Notice that I'm using my full calculator displays. Really I should use this one, 0.023584, but it doesn't really change the values much. So we do that, and we get 10.01, but you need a full number, so this is where you just knock it off and round it off to 10. So x is 10. And that's it for this tutorial. Thank you very much for taking part, stroke watching the answers, because you might not still understand it, but I hope you understand it a little bit more after watching this video. So thank you for watching.